So far, we described compounds as follows. Water is a molecular compound made up of molecules that each consist of 2 hydrogen and 1 oxygen atoms. In chemistry, this information is typically conveyed using the chemical formula of a compound. For water, the chemical formula is H2O. Let's look at the components of this formula and at what it tells us about the compound. The formula includes the element symbols for hydrogen, H, and for oxygen, O. Because both hydrogen and oxygen are nonmetals, it is likely that the compound described by the formula is molecular. It is not always the case. We will soon encounter compounds that are ionic even though they contain no metal atoms, and we will learn how to recognize them. However, the majority of compounds that contain no metal atoms are molecular, and water is one of them. The formula also includes a subscript, 2 following the symbol for hydrogen. That indicates that there are 2 hydrogen atoms in a water molecule. No subscript follows the symbol for oxygen. If there is more than 1 atom of an element in the molecule, the symbol of the element is followed by the corresponding number in the subscript, but the subscript 1 is simply omitted. Chemical formulae can be written for both molecular and ionic compounds. In the latter case, the formula is written for the smallest unit of a compound rather than for a molecule. Thus, the chemical formula for sodium chloride table salt is NaCl, because the ratio of the number of sodium atoms to the number of chlorine atoms in this compound is 1 to 1, so the simplest unit of this compound consists of 1 sodium atom and 1 chlorine atom. The aluminum oxide, a compound that consists of aluminum and oxygen atoms at a 2 to 3 ratio, the chemical formula is aluminum 2O3, because the simplest unit of aluminum oxide consists of 2 aluminum atoms and 3 oxygen atoms. A formula that gives the simplest whole number ratio between the numbers of atoms of different elements in a molecular compound is called an empirical formula. For ionic compounds, the empirical formula is the only type of chemical formula that we need to consider. For molecular compounds, however, it does not tell the full story about a molecule. Consider 2 chemical substances. Acetylene, a colorless gas that is used as fuel for welding, and benzene, a colorless flammable liquid that is a component of crude oil and is responsible for the characteristic smell of gasoline. An acetylene molecule is made up of 2 carbon atoms and 2 hydrogen atoms, so the smallest whole number ratio of the number of carbon atoms to the number of hydrogen atoms is 1 to 1, and the empirical formula of acetylene is therefore CH. A benzene molecule is made up of 6 carbon atoms and 6 hydrogen atoms, so the smallest whole number ratio of the number of carbon atoms to the number of hydrogen atoms is also 1 to 1. And the empirical formula of benzene is therefore also CH. However, acetylene and benzene are different substances with different properties because for molecular compounds it is important how many atoms are joined together by covalent bonds to form a molecule. Therefore, in addition to the empirical formula, for molecular compounds we also define a molecular formula that indicates the actual number of atoms of each element in one molecule of the compound. For acetylene, the molecular formula is C2H2, and for benzene, it is C6H6. For some molecular compounds, the empirical and the molecular formula may happen to be the same. Water is an example of such a compound. The smallest whole number ratio for the number of hydrogen atoms to the number of oxygen atoms in water is 2 to 1, So the empirical formula for water is H2O. However, the actual number of hydrogen atoms in one water molecule is 2, and the actual number of oxygen atoms in one water molecule is 1, so the molecular formula for water is also H2O. For many other compounds, however, the empirical and molecular formula do not coincide. In such cases, the subscripts in the empirical formula are smaller than the subscripts in the molecular formula. It's what we see for acetylene and benzene, that have molecular formulae C2H2 and C6H6 respectively, but both have the empirical formula CH. For molecular compounds, the way in which atoms are connected to each other is also important. For instance, a benzene molecule consists of 6 carbon atoms that are arranged into a ring, with 1 hydrogen atom bound to each carbon atom. However, it turns out that it is also possible to connect 6 carbon and 6 hydrogen atoms in another way. 3 carbon atoms form a triangle with 1 hydrogen atom attached to each carbon. Then 2 such triangles are connected together, as shown on the slide. This compound is called bicyclopropanol, and it has very different properties from benzene, even though its molecules are made of the same numbers of the same types of atoms. Benzene and bicyclopropanol have the same molecular formula. Such compounds are called isomers. To distinguish between them, one can use so-called structural formulae that show the covalent bonds that connect atoms with dashes. We will talk a little more about structural formulae later in the course.